Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dokpo Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to prove the derivative of the general logarithmic function y equals to log of x of base a. So we know that the derivative of log of x of base a is equal to 1 all over x ln of a. But how did we actually arrive at this? That's what we want. So these are some useful hints that we're going to use. Now, we're going to use the first principle of derivative to prove this, and we will also use the natural logarithm to also prove this. So let's start with the first principle of derivative. So now we have f of x. We need to identify our f of x, because within this formula, this is the first principle of derivative. F prime of x equals the limit of f of x plus h minus f of x divided by h as h approaches 0. So we need f of x, which is the original function, and we need to derive f of x plus h. So what is f of x? F of x now is what you are about to differentiate. So f of x is equal to log of x base a, and f of x plus h is equal to log of x plus h base a. Now, f prime of x now equals the limit. So that's where we see this expression. We're going to write this one, log of x plus h is a minus log of x is a divided by h as h is approaching 0. Now, at this point now, our focus is to rewrite this limit into the standard limit that we have here. That is the limit of 1 plus x over a. Now this would be h over some x, right? H over some x, or raised to the power a over x. That is x now over h. So we can first factor out this h. So f prime of x, the limit. So if we factor out this h, 1 over h, bring it outside so that it goes to the power of the log. Now, log of x plus h minus log of x, we can bring in this property, the difference property. That is log of this expression divided by this. So it's x plus h divided by x as h approaches 0. So now we have f prime of x is equals the limit. So this becomes the power now of this expression. So we can also simplify in here. So we have log x over x is 1 plus h over x raised to the power 1 over h of a as h approaches 0. Now we can factor out this log. So f prime of x is equal to log of this a, the limit 1 plus h over x raised to the power 1 over h. Now, if you look at this standard limit, you have x over a, and the power is a over x, almost like the reciprocal, the reverse of this expression, right? So this is h over x. So here must be x over h. So if we just rationalize x, we can take this x and bring it right here, and take the 1 and bring it on this side. So h approaches 0. So this entire thing in here will just be equal to some e. So we have f prime of x equals to log base a of some e raised to the power 1 over x. So this 1 over x, using this property, the 1 over x can come down. We have f prime of x is equals to 1 over x log of base a of e. Now there is something called change of base. Now this log of base a of e can be rewritten as log of base e of e all over log of base e of a. So we have changed the base 1 over x. So log of base e of e, we know that this is, when the base is e, is a natural logarithm. So we can even rewrite this as ln of e all over ln of e. Now there's 1 over x outside. What is ln of e? Ln of e is just equals to 1 and then ln of a. So this is just 1 all over x ln of a, f prime of x. So this is how we find the derivative, or this is how we prove the derivative of log of x base a using the first principle of derivative. Now, this is for the case where the coefficient of this x is 1. What if the coefficient of this x was not 1, or this x as a whole was a kind of function like, say, sine of x or x squared or x squared plus 1, whatever the case might be, right? So what if this was not just a linear function x raised to the first power, that is 1x raised to the first power? What if it was something else? So the general form d bar dx of log of some u of base a is now equal to 1 all over x, or let's say we have u now, u ln of a times the derivative of u times the derivative of u. Or we can call this, like, say, u prime, because we are differentiating u with respect to x. So that is the general form. Now, let's move to finding, let's say, proving this the shortcut way, that's not to go this long route, right? So using the exponential form and the natural logarithm. So we know that y equals to log of base a of x. So rewriting this in exponent form, this is the power, this is the base. So base a raised to the power y equals to x. So now we have a raised to the power y equals to x. So we can take the ln on both sides. So we take the ln on this side, and we also take the ln on this side. So this power will drop, y ln of a equals ln of x. So we can now differentiate. This is a constant, so we hold the constant and differentiate y, we get y prime, because y is the name of the function. And then we differentiate ln of x, we get 1 over x times the derivative of x, which is just 1. So now you see that we now have ln of a being divided on both sides. So ln of a cancel ln of a. Y prime is just equal to 1 over x ln of a. So you see how this one is very, very short, just few steps, and then you are done with the problem. So thanks all so much for watching. See you in our next lesson, where we will solve more problems on the finding derivatives of general logarithmic functions. Thank you.